So what on earth could connect the cold, hard logic of computer code with, say, the deep interpretation of a novel? It sounds a little crazy, right? But believe it or not, there's a hidden language that links them. Today, we're going to go find it.
Okay, so look at this. On one side, you've got a computer compiler optimizing machine code. That's a world of pure logic, efficiency, speed. On the other side, postcolonial literary theory, a world of ambiguity, history, and messy human meaning. I mean, these two don't just seem different, they feel like they're from separate planets.
And that brings us to our central riddle for today. What could a compiler and a critic possibly have in common? Seriously, how can making a computer run faster have anything to do with analyzing a story? Well, the answer, as it turns out, tells us something really fundamental about how we make sense of, well, everything.
To solve this, we need to kind of shift our perspective. We have to stop looking at what these fields are about and start looking at the language they speak. And that language, it's all about structure. And here it is. This is the big secret. Both a computer compiler and a literary critic are experts in structure. They're trained to look right past the surface, whether it's a line of code or a line in a book, to see the hidden blueprint, the skeleton that's holding the whole thing together. So, at its most basic, a structure is just a simple hierarchy, kind of like a tree. You can see it here. An encyclopedia branches out into science and culture, and those branch out even further. It's a really basic way we organize information, right? Going from the big idea down to the specifics.
But, things in the real world are rarely that simple. They're often more like this complex network, which is sometimes called a polytree. Now, notice here how a single point, D, it connects to multiple parents and multiple children. This isn't a simple one-way street anymore. It's a whole web of interconnected relationships. Definitely keep this idea of a network in your head.
All right, let's see this whole idea in action. We'll start in the world of computer science with a program that's working silently inside your computer right now, making everything run just a little bit smoother.
That program is called a compiler. Now, its job sounds pretty straightforward. Take the code a human writes and translate it into the ones and zeros that a processor can actually understand. But here's the thing. The goal isn't just to translate. It's to translate it perfectly and as efficiently as possible.
In a perfect world, a computer processor would work just like this. This is what you call a standard pipeline. Fetch an instruction, decode it, execute it, and so on. It's a clean, step-by-step assembly line. One thing happens right after the other. Nice and simple.
But reality is messy. Sometimes, one instruction needs a result from the one before it, but that result isn't ready yet. This creates a huge bottleneck, basically a traffic jam on the information superhighway. The processor just has to sit there and wait, which wastes precious time.
And this is where the compiler's genius really comes into play. To solve these traffic jams, it doesn't just read code line by line. No, it sees the code as a structural tree, just like the ones we saw a minute ago. By analyzing that structure, it can spot patterns, it can reorder instructions, and find the absolute most efficient path to get the job done, getting rid of all those wasteful pauses. So to sum it all up, the compiler is a master translator. Its goal is pure clarity and maximum performance. It takes a human's kind of abstract instructions and finds the single best, fastest, most logical way for the machine to actually execute them. Okay, now let's pivot. Hard. We're leaving the clean, logical world of the machine, and we're diving into the complex, kind of ambiguous world of human stories. And here, the goal is not perfect translation. It's something else entirely. So, postcolonial literary theory looks at texts that were written in the shadow of empire. A critic's job here is to analyze the structure of these stories to understand how they're dealing with things like history and power and identity. They're basically listening for the voices that have been pushed to the edges of the story.
And this is where the critic's job gets really fascinating. They don't just look at what's in the structure, they look for the gaps. As this quote explains so well, sometimes the most important part of a story is what isn't said. These silences, they are also structural choices, and they often reveal a difficult truth that the narrative itself is trying to dance around.
So let's put them side by side. The contrast is pretty stark, isn't it? The compiler analyzes structure to create efficiency and clarity. It wants one single, perfect translation. The critic, on the other hand, analyzes structure to find revelation inside of all the ambiguity. They're hunting for hidden meanings, for tensions, for the things the structure itself might be trying to hide from you. So we've got two different worlds, two totally different goals, but they share one method: analyzing structure.
So you might be thinking, is there anything out there that can actually bridge this gap between machine efficiency and human meaning? Turns out, there is, and you probably use it every single day.
This is Wikitext. It's the code behind every single article on Wikipedia. It might look a little weird at first glance, but it's a perfect hybrid language. It's simple enough for a human to write and understand, but it's also perfectly structured for a machine to understand and process. Just look at these examples. You've got these simple commands using brackets and curly braces that create really complex things on a web page. A couple of square brackets and boom, you've got an image. Those curly braces, that's a quote. You can build a table, you can add a citation. Each command is a clear structural instruction.
And this is the magic of it, right? It's the perfect middle ground. Wikitext proves that we can create languages that serve both of these masters. It allows for human expression, but it does it within a formal structure that a computer can translate perfectly every single time. It really is the best of both worlds.
So we've connected the machine and the novel. What's the big takeaway here? Why does any of this matter? Well, because once you start looking for these hidden blueprints, trust me, you are going to see them absolutely everywhere.
Just think about it for a second. The company you work for, the laws of your country, even the unwritten rules of social etiquette. These are all structures. They're abstract hierarchies, just like this diagram, and they dictate how information flows, who has power, and what's even considered possible in the first place.
And that is the real power here. Understanding structure lets you play both roles. You can be the compiler, building new, more efficient systems, and you can also be the critic, analyzing the systems we all live in, seeing how they really function, and asking why they were built that way to begin with.
So I'll leave you with this question to chew on. As you go about your day-to-day, at work, in your community, watching the news, ask yourself, what are the hidden rules? What are the invisible blueprints that are shaping what you see and what you do? Because finding them, that's the first step to understanding everything else.